Hi guys, in this video we're going to be looking at RF values and then the factors that affect RF values before finishing off with a summary.
If you've watched our video on chromatography, you'll know that chromatography is a physical process which allows us to separate and identify the components in a mixture, specifically when that mixture is in solution. We can use the results from a chromatography experiment, which is the chromatogram, to calculate a useful method of comparison known as an RF value. The definition for an RF value is the distance travelled by the dissolved component divided by the distance travelled by the solvent front. The RF value is useful because each compound will have a unique RF value, which will have been found by repeated experiment and will be recorded in a data booklet. Therefore, if you calculate an RF value from an experiment, you can look in the data booklet and match it with a known RF value, allowing you to identify what that component is. If we look again at the definition of the RF value, which is distance travelled by dissolved component divided by distance travelled by solvent front, we can see that the further a dissolved substance moves, the larger the RF value is going to be. Let's have a look at an example. This diagram shows the results of a paper chromatography experiment. Marked on is the origin, or pencil line, which is drawn at the start of the experiment, where the substance to be tested is placed. You can also see the position of the compound at the end of the chromatography experiment. There's also a line drawn for the solvent front, which is the furthest point reached by the mobile phase during the experiment. We can therefore define two useful distances, the distance travelled by the compound and the distance travelled by the solvent front, and these are the two values that we need in order to calculate the RF value. In this case, the RF value will therefore be equal to the distance travelled by the dissolved component, which is 2.1 centimetres, divided by the distance travelled by the solvent front, which is 2.8 centimetres. If you put this into a calculator, you can see that the RF value for this component of the mixture is 0.75. There's two important things to note here. The first one is that RF values are always between 0 and 1. Therefore, if you get an answer that's greater than 1, you'll need to stop and check your working. This is because the solvent front should be the furthest distance travelled by the mobile phase during the experiment, and therefore the denominator of this fraction here should always be larger than or equal to the numerator. Secondly, the RF value has no units. This is because the distances travelled should be in the same units, which will then cancel out in the division. In this example, we can only see one spot, suggesting that this is either a pure substance.
Hi guys! To continue watching this video and unlock hundreds of other super concise and exam board specific GCSE chemistry and combined science videos, just click on the Snap Revise smiley face. Join me today and together let's make Chemistry at GCSE a walk in the park.